once our brain ends up registering a stressor, once we've determined that something in our environment is causing us to sort of have a stress response, we start to see this reaction or activation in both our autonomic nervous system, the ANS, and in our hypothalamic pituitary adrenal axis, or HPA axis. We're going to talk about both of these sort of chains of reactions, and we can sort of see them both of them up here. We're going to be focusing on the yellow, sort of yellowy orangey one first, looking at our autonomic nervous system. And so you might remember from 104, when you were talking about all of the different parts of our nervous system, that our autonomic nervous system is the stuff that happens automatically. So things that are going to happen without conscious input. And we have two distinctions, two separate types of our automatic nervous system, or I guess categories within our automatic nervous system. And this is our sympathetic nervous system, or SNS, and our parasympathetic nervous system, or PNS. And so these two systems are going to work sort of in contrast to one another, where one of them is going to be ramping up our body responses, and one is going to dampen or wind down those responses. And so these two systems are going to work together in opposition to maintain a homeostasis or a balance within our body. So let's start with the sympathetic nervous system, because that's the part that's ramping up our automatic nervous system. So this is responsible for our fight or flight response. So this prepares our body to either fight or flee when we're faced with some kind of stressor. Our hypothalamus, which is located in here at the base of our brain, is going to be responsible for coordinating our autonomic nervous system responses. So whether we activate our sympathetic nervous system or our parasympathetic nervous system, that's all going to run through our hypothalamus. Activation of our sympathetic nervous system is going to promote the release of a stress hormone, actually a couple of stress hormones, and we can call this whole group the catecholamines, is the whole term there. Oh my goodness. But mostly we're going to call these epinephrine and norepinephrine, because those are the two most common of those hormones. And they are going to play a really big role in preparing our body for that fight or flight response. So epinephrine and norepinephrine are hormones that are released into the body, and most hormones are going to travel throughout the body by circulating in our bloodstream. So even though they're released in the brain, they can then have an impact, an effect on the rest of the body as well. And as a result of the presence of this epinephrine and norepinephrine, we start seeing things like dilated pupils. So our pupils will get larger to allow in more light, which will let us see more detail, which if we are in a fight or flight situation, maybe we're facing off against a predator, we've bumped into a bear. Looking for an escape or watching for different things in the environment is going to be really important. We also see slow digestion and dry mouth. So this is basically the idea that we can't waste energy on digesting food. We don't want to waste anything with sort of non-essential systems. We're going to focus on other things like watching for threats, for reacting to that threat, and potentially getting ready to either run away from that threat or engage that threat directly. We start seeing things like a flushed face, which would be an increase in our blood pressure and heart rate. We end up having what's called tunnel vision, where we start focusing in on basically the focus of our threat. So the thing that we find threatening, we're going to focus all of our attention on it. And then we're going to have lots of energy mobilized in our body because we're getting ready to either fight or run away. So this is all instigated by stimulation of our central nervous system that leads to the release of our epinephrine and norepinephrine. And we're going to see that these effects aren't just driven by epinephrine and norepinephrine. We can already kind of see that cortisol is going to be involved as well. But I figured we'd talk about all of these different physical effects here and then continue on to talk about our hypothalamic pituitary adrenal axis, or the HPA axis. So, the same way that our brain areas can activate our hypothalamus to stimulate our central nervous system, or our sympathetic nervous system, we can also have our brain areas, specifically our amygdala, sort of reacting with the hypothalamus to trigger this HPA axis. And so the steps here is that our hypothalamus is going to be triggered to release cortico tropin releasing hormone, or CRH. And then CRH is a hormone, so it's going to circle through our bloodstream and it's going to act on our adrenal glands. And our adrenal glands, oh, I apologize, I skipped a step there. Before I get ahead of myself, so our corticotropin releasing hormone CRH triggers or stimulates our pituitary gland first. The adrenal glands are going to come later. So CRH activates our pituitary gland. The pituitary gland is then going to release adrenotropic hormone, or ACTH, and then that adrenotropic hormone is going to itself stimulate the adrenal glands, and the adrenal glands are then going to release cortisol. So we have this sort of chain of events where we start at our hypothalamus, hence the name here. It's going to then trigger our pituitary, and then it's going to trigger our adrenal glands. That's why this axis is named what it is, because it involves the hypothalamus, the pituitary, and then the adrenal glands. And as a result, it's going to release cortisol. And cortisol is a stress hormone. And so we have cortisol levels fluctuating normally throughout our sort of everyday lives. But when we are faced with sort of really intense stressors, we're going to have more of it released, and then we're going to start seeing some of those physical effects. So cortisol, as well as epinephrine and norepinephrine, are our stress hormones that are going to lead to this sort of fight or flight response. Now, there's been tons and tons of research on stress that tends to focus in on cortisol. It is one of the most widely studied hormones, and especially to do with stress. So it's really convenient because you can measure cortisol levels in saliva and blood and even hair samples. So it's really easy to monitor it. And we tend to see a pretty quick sort of uptick in our hormone levels, or in those cortisol levels. So as quickly as 15 to 20 minutes after exposure to a stressor, we can actually register those levels of increased cortisol in either saliva or blood or whatever we're collecting. And so we can look at a bunch of different sort of reactions in how long we react to things and which things are producing more or less cortisol in order to determine sort of how stressful a different thing is. So it's a very well-studied and very interesting stress hormone. And so that's our fight or flight response. And then I kind of skipped over it, but we focus mostly on that sympathetic nervous system and ramping up for the fight or flight response, and our HPA axis sort of getting us ready to deal with stress. But our parasympathetic nervous system also plays a really important role by sort of dampening our stress response. So as we're having these stress responses, as we're getting ready to fight or flight, if we can leave that stressful situation, we want to get back to our normal homeostatic balance. And the parasympathetic nervous system is going to act in the opposite direction of the sympathetic nervous system to get us back to normal. So our pupils would go back to the normal size, our digestion would pick up again, our mouth would stop being dry, our heart rate and blood pressure would go back to normal, and all of those things. So everything would reset. So these two systems act sort of in contrast to one another and would work together to get us back into balance once that stress has passed. And so we typically talk about fight or flight responses, but we actually also have a third option. So it's not just fight or flee, we can also see a freeze response. So sometimes an individual will become immobile in the face of perceived stressors. So if you think of possums and the fact that they play dead when they experience sort of fear. So if they're faced by a predator, they might sort of keel over and play dead. so that they're no longer a threat, so that they get ignored, and they can go off on their way. We also experience these freeze responses. So maybe if you have stage fright and you had to go up and give a speech, standing before the crowd, you might have that sort of, I can't move, I can't speak, I can't do anything, and that would be a freeze response. So instead of trying to fight or run away, we would just freeze up. And so we tend to experience these freeze responses when we have stressors that are very intense and stressors that are something that we cannot control. But there's lots of research looking at sort of what do we do? Are we more likely to fight or flee or freeze? And it depends on the individual and the situation and a whole bunch of different moving factors. And so I've been talking about all of these different systems kind of working together and activating each other and doing all of these different functions, but we haven't really described anything about the mechanism of regulation. So how do we get back to normal? How do we switch from our sympathetic nervous system to our parasympathetic nervous system? Which one is active and in which ratios? So this is the process of regulation. And a lot of regulation within our body relies on feedback loops. And typically, we're going to have either a positive feedback loop or a negative feedback loop. And these feedback loops basically say that output from one of our systems is going to influence the output of another system. So in a positive feedback loop, increase in output from one system will cause an increase in output from another system. So as more stress hormones are released, maybe more other stress hormones would be released. That would be a positive feedback setup. In our sort of negative feedback setups, that's when increased output from one system ends up inhibiting a second system. And actually, most of our stress responses, and specifically our HPA axis, is going to rely on these negative feedback loops. So in that HPA axis, if we go back here, sort of as this CRH and ACTH and cortisol are released, presence of those levels within the body will actually lead to sort of lesser production of them in the future. So even if the stressor persists, this HPA response is going to gradually lessen over time. So that's probably beneficial, because if we were facing a chronic stressor, we might end up with very, very high levels of cortisol, our stress hormone, if we had a positive feedback loop. So this way, the more stress response that we produce, the more we tell our body that it needs to stop being stressed. So it's going to try and shift us away from that stress response as quickly as possible, because it isn't necessarily healthy to sit at high levels of stress. Our autonomic nervous system also works by the process of reciprocal inhibition. And this is just sort of the fancy way of what I've been talking about, where our sympathetic and parasympathetic nervous system act sort of in sort of contrast to one another. So our sympathetic nervous system is our activator. So it's going to ramp up our nervous system. And our parasympathetic nervous system is going to be a regulator or an inhibitor. So it tries to bring our levels down. And so they're going to inhibit each other. So as the sort of sympathetic nervous system is getting higher, we're going to have less of the inhibition, and then we can sort of shift back the other way. So they're going to almost play tug of war with one another and find a balance in the middle. So those are our different categories of regulation. And the last thing I wanted to talk about here is our immune system. And so we've kind of mentioned the fact that existing at very high levels of stress long-term might not be a great thing. Short-term stress responses, things like being ready to deal with fight or flight, can be beneficial. And even our inflammatory response can be beneficial. So if we think about it, an inflammatory response is just our immune system responding to injury or infection or psychological stressors that might cause bodily harm to us. So in this case, if we're in a fight, Maybe we get cut. Maybe something breaks our skin. Maybe we get bit by something. And that's a potential source of longer term injury, of infection. So our body is ready to handle those potential wounds in order to heal faster and avoid sort of having problems down the line. So we have an increased sort of immune response when we experience stress at first because it's adaptive. It gets us ready to deal with any injuries that we have, helps us heal faster, and allows us to sort of continue on with our lives a little bit better. From my wording, you've probably picked up on the fact that prolonged or very extreme levels of this inflammatory response can end up being problematic, but we'll discuss some of the negatives a little bit later on. For now, we're focused on this idea that, yeah, it can be beneficial to be ready to repair any injuries that we suffer during a fight or flight response. And when we encounter these acute psychological stressors, so not even physical stressors, anything psychological will do so as well, we see an increase in levels of proteins called cytokines. And these are involved in regulating our inflammatory response. So they're just going to make sure that we have an increased inflammatory response when we're faced with psychological stressors as well as physical stressors.